First practice on lead code, 50 to 60 medium question. After that, you can start from CodeForces. So it will be more good, or you can also start with, like, if you are comfortable with some level of question, like some algorithm based question, like binary search type. So you can also start from CodeForces. But I will must say that first do 20 to 25, at least 20 to 25 medium level question on lead code, not just simple one. Yeah, A to J ladder. Okay, that's good. Yes, you can start. If you are comfortable with those level of question, you can start. But also I will suggest that with CodeForces also do practice on lead code, because see, there you will get some more algorithm. So those algorithm will help you in solving competitive coding question. Okay. Yes, vector. Yes, STL this question. So don't worry, if you are joining our workshop, in that I will tell you that how lead code work, how lead code functions that work. We will also covering lead code in that, because lead code is necessary for practicing these type of questions. So I will cover that. Okay. So I think we should start now. So let's see how many people are in the. Okay. So there are a lot. Okay, so we are going to see this first problem, beautiful numbers. So they are, we have given an array from 1 to n integers, and this is the permutation of those numbers. Okay, so we will get a random order from 1 to n numbers, and we have to find from that 1 to n number how many numbers are beautiful. Like, so what is the definition of beautiful number here? That a integer k is a beautiful number if in array there exists a sub-array of size k with permutation of 1 to k numbers. Okay, so let's say in this example, there are 4, 5, 1, 3, 2, 6. This array is given to us, and in this we have given 1 to 6 number. So we have to find that 1 is a beautiful number or not, 2 is a beautiful number or not. So we have to return a string that if 1 is a beautiful number, then it here will come 1, and 2 is not a beautiful number, so we have printed 0. So I will tell you this with the help of example. Let's say, what was our array? It was 4. Wait a second. Getting problem. Okay, so it was why. Okay, 4, 5, 1, 3, 2, 6. So see, here 1 is a beautiful number because there exists an array of size 1 with the permutation of numbers till 1. Now see, if we take an array with has 1 to 2 number, now here the size of the array is 3, but we have no array, no sub array such that we have 1 to 2 number and the size of array is 2. So here 2 is not a beautiful number because the size of this array is 3. Now we will see that here exists a sub array with has 1 to 3 element, and the size of this sub array is 3. So 3 is a beautiful number. Now we will see that if we take a sub array with has 1 to 4 number, smallest sub array, that is this. So here the size of the array is 5. So now this is 4 is not a beautiful number because the size of this sub array should be 4. So now we will take 1 to 5. Then if we take 1 to 5, then yes, here exists a sub array with permutation from 1 to 5, and the size of this sub array is also 5. So here 5 is a beautiful number. Now we will take till 6. So see here exist a sub-array 1 to 6 numbers, and the size of this sub-array is 6. So here 6 is also a beautiful number. Now I am giving you just 2 minutes. Can you make any approach to solve this question? Like how can we tell a number is beautiful or not? How can we written? Just do fast. After that, I will tell you the solution. How? Like say, yes. Uh, okay. Uh, there is a sound around you. I can listen you properly. Hello. I think you are saying that we will traverse all sub-arrays of this array, and in that we will see that there is a combination from 1 to that number, that size or not. Am I right? So see, in that case, the complexity of our program will be O(n) square. But here, if you will, hello, please mute yourself. Uh, but here you will see that our input size is 10 to the power 5. So we have to make a O(n) solution, because if you make a O(n) square solution, then it will become 10 to the power 10. So you will get the time limit exceeded. So we want to make a O(n) solution for this one. So see, now your approach is right, but it is not the given time complexity. So see what we can do, that in this we are needing index many times. So first we will do, we will create a map for that, in which we will save all the index of that sub-array. Like say 4 has index 1, 5 has index 2. So from here we will get the index of that number in O1 time. Okay. So one has the index and so on. Now see what I will do, that we know one is always a good sub-array. Wait a second. Uh, there is a problem in joining someone. Wait a second just. Okay, so we will see, we know that one is always a good sub-array because it has always one size. So first we will take one and a lower bound of our sub-array and the upper bound of our sub-array. So for one, lower and upper bound both will be what, index of this. So we will get the index of this. So am I audible now? Hello. Okay, so for one, the lower bound and upper bound will be 3, 3. So now what will be the size of that sub-array? Size of that sub-array will be upper bound minus lower bound plus 1. So here we will get the size 1. Now we will come to 2. So see, what is the index of 2? Index of 2 is 5. So we will check that if that index is in our range, previous range. So no, that is not in our range. Now we will see that if it is less than lower bound, then we will shift our lower bound to that element. And after that, we will check that if it is greater than our upper bound, we will shift our upper bound to that element. So here it is 5. So we will shift our upper bound to 5. So now we will get the size of a sub-array which has 1 to 2 element. So we will get the size of this sub-array. This is 5 minus 3, 2 plus 1, 3. So see, it is not equal to the index, so it is not a good sub-array. Now we will take 3. So what is the index? What is the index of 3? Index of 3 is 4. So that is inside our range, previous range. So we have not to update anything. We will take 3 to 5. Just so now what is the size of this sub-array? 5 minus 3 plus 1, that is 3. Now we will include 4 for to check 4. So what we will do, we will see from this map the index of 4. So that is 1. It is less than our lower bound. So we will shift our lower bound to 4. So that is index 1 and our upper bound will be the same. Now what is the size of this sub-array? it is 5 minus 1 4 plus 1, that is 5. So it is also not equal to our number, so it is not a good number, beautiful number. So now we will include 5. So what is the index of 5? It is 2, that is in our range. So we will not include, we will not update anything. We will take 1 to 5. And what is the size of this sub array? 5 minus 1 4 plus 1 5. So 5 is a beautiful number. Now we will take 6 and we will check the index of the 6. So index of the 6 is 6. So we will update our upper bound, that will become 6. Now what is the size of this sub array? 6 minus 1 5 plus 1 6. So it is equal to 6. So how many beautiful number we get? 1 is equal to 1, so it is beautiful. 2 is not equal to 3, so it is not. And 3 is so yes, and 4 is so not, and 5 is so no. So I think the approach is clear to you, right? The approach is clear to you. So what we have to do in this case, we have to just traverse our array once. Okay. Hello, am I audible? Okay, so approach is clear to you. Okay, so now we will see the code for this same. See here, this is the beautiful numbers. So see, we have done the same thing in this, that we created a map for the index of the index of each number. So at the time of taking input from the user, we are also saving its index in this map. I have also taught you STL in previous lecture, so I am using this map from them there. So at that time, now we have the index of each element in this map. Now for 1, see, we have set here, we have set our previous lower and upper at the index of 1. So I am getting the index of 1 and assigning it to low, and after that I am getting the 1 and assigning it to high. Now we will check from 1 to n that it is a beautiful number or not. So see how I am updating that. If the index of our current element is less than low, so we will shift our low to that index, and if our current index is greater than high, then we will update our high to that element. So now we will check that if high minus low plus 1 is equal to our index, then we will print cout 1, and else if it is not, then we will print 0. So we will submit this code on CodeForces. So who have joined who has joined late, just try to understand from the second question. That will be clear to you if you missed something in this question. So I will submit the code for this. My net is slow. So okay. So here we have put the code, and after that we will go for beautiful numbers. So here I have submitted my code. Now let's see it get accepted. Wait, there is something. You have submitted exactly the same code before. It is, I think here it should be. Wait a second, I think there is something network problem. Okay, so it get accepted. Okay, so now, so I think this question is clear to you. Now we will see other question, sequential NIM. So wait a second, before this we will see another question, that is when you play chess. So I have taken this question simpler than previous one. So this will be more clear to you. See, I am giving you just a glimpse of the CodeForces, that how many type of question they ask you. So it is it is like a pattern printing question. So what is the question? That we have given us a chessboard of size n into m here. So n is the row and m is the column. So, and we have given a position sx and s5, and that is not near the corner lines. So it is greater than 2, and it is greater than 2 and less than n minus 1, m minus 1. So we are in the mid of the chess anywhere. So we have given x, y. Now it is telling us how we can move in the chessboard. So it is saying that by can to change by dash. That means we can move in the column. And also it is saying that xy can go to x dash y. That means we can move in a row. So it is like a rock. It can move in column, and it can move in row. So now our goal is to visit each cell exactly once. So we have to traverse the each cell once. Now the only line we have given just n and m, that is the size of the array and our first position. So we have to print, see here 3 into 3, 9 cells. So we have printed all the 9 cells. Okay, so this is the output for the same. Now see, I will tell you the question by just an example. So see, this is our chessboard. I am taking just a random chessboard, and wait a second. So this is, I just see how many lines it takes, because I have not decided anything before. So let's say I am making a chessboard. So okay, so this is our chessboard. Now we can't stand at the corner place. So let's say we are standing here. Now our target is to traverse the complete chessboard without traversing same cell again and again. So what and the other condition is also, see, if you can go from here to here direct, in that case these two cells will not be traversed, and also you can jump or cross any cell. So yes sir, I am recording it. So okay, so see, how can you do this? Let's say a simple question. If I am standing here and I want to traverse the complete chessboard. So what we will do? Just we will go from here to here, here to here, here to here, and in this way we can traverse the complete chessboard. But in this case, he is saying that we can't stand from. Sir, may you please use Hindi to explain? See, there are also many people from South, so they can't understand Hindi proper. So I think the English is the language in which they will understand. So okay, I will try. Okay, okay. So see, मैं आपको क्वेश्चन बता देता हूँ हिंदी में कि हम यहाँ पर खड़े, सी हम कॉर्नर पे खड़े नहीं हो सकते हैं, कहीं मिड में हम खड़े हैं, हमें ये पूरा कंप्लीट चेस्ट ट्रेवर्स करना है. सो व्हाट वी कैन डू, अगर सी मैंने आपको बताया कि हम यहाँ खड़े होते तो बहुत आसान हो जाता, हम इस साइड पूरी फर्स्ट रो ट्रेवर्स कर लेते, आफ्टर सेकंड रो, आफ्टर थर्ड रो, एंड आफ्टर फोर्थ रो, देन फिफ्थ रो. सो but in this case, see, now the case is also the same. What we will do, that first we will traverse all the block from the right. So first we will go here, and after that we will start from here and will traverse this complete row from here to left. Now what we will do, we will just jump from here to the first index. We can do that because this is the row. So now from here we will do the same. We will traverse the complete right block. After that we will complete traverse the left block. After that we will traverse the complete right block. After that we will get this row which we have also traversed before. So we will skip and we will start from here, and after that we will traverse the complete row. You can also do it in a different way. This is the algorithm which I am using in the code. So now let's see the code for the same. Okay, so this is the Wobunyu play chess. See, in this we are going to do the same thing which we have discussed in our algo. So here we are taking n, m, x, y, that is size and array. And also, so first what I said, that we will traverse the right block. So I am starting from y and will go to the end block, that is m. And see, in this case our row is consistent, so we are printing x, we are not changing anything in the x. And in I is our current block. So we are changing the block. So we will traverse the complete right block of X row. After that, we want to traverse the left block or left block. So I am starting from by minus 1. See, by to m we have printed. Now we have to print by minus 1 to 0. So that row will be traversed completely. So we are printing the same row X and we are printing I. Now we have come to the, I have told you that we will now we will start from the first block. So in that case, we also need to maintain the direction, because once we have got at the end block, then our direction will be changed. So I am denoting 0, that we are going to left to right. And if direction is 1, then it means we are going from right to left. So what I am doing, that we will traverse the 1 to n. N is our number of block in that number of rows. So see, I have taken this constraint, that if I is equal to x, because we have traversed the x row. So we will continue, we will skip all the code if I is equal to x, because we have traversed that row. So now see, if direction is 0, that means we have to go from left to right. So I have taken 1, we are going to 1 to m, and we are printing the I to j. And after that, our direction will be changed. So I have taken here direction is equal to 1. See, if direction is equal to 1, so we have to traverse from right to left. So I have taken j is equal to m, and decreasing j each time, and we will go to till 1. So I have printed also the same. So let's say, wait a second, here I need, okay, so I think it's right. Okay, so now we will submit the code. Yes, yes, it is given. See, nm is the size, and this is x by, it is our first position. From that we have to traverse. Okay, xy is given to us. What the question is not clear. uh, no, it can be anything, anywhere in this portion. It will not be in the last line or last row. See, it cannot be here in the corner lines, but it can be anywhere in this mid block. Okay, it can be here, it can be here, anything, anywhere. Okay, so okay, I am going to submit the code now. See, these are not the A problem. These are B problem from each contest, and this is the division 2, and last one was also the division 2. So you have now idea that how much level of those they asked question in their round. So I think it is in queue and submitted successfully. So these are some previous call. First I preferred Python, but now after from a long time I am doing it in C++. So I think there is also a network issue, because I am wait a second, it has something, it is also giving the wrong answer on first test case. By wait a second. Okay, it is also printing n3 and 2. I think something is wrong with this code. Wait, I think I have to print. Okay, instead of backslash n, I was printing something. Or should I take it? Okay, I think it's right now. Submit code. So this is the level of the question, and I think it was at the 1300. So till then it's running. Okay, so till then it's running. I will tell you the what is our next question. So it is sequential name. It is the game based question. You will get to know that there are always in if you will traverse to one or two or three contests from division 2, you will get a question game. Okay, so, okay, this is previous. Where that summation go? It's still running. I think there is a network problem also, so it is not running properly. After that, sometime we will see it. Till then, we will see our third question. So this is the sequential NIM. So in what is the question that we have given an array of n piles, and each pile has some number of stones that will be given in our AI. So we will see that what is the problem. There are two players, and a player can take any number of stones from the first non-empty pile. It cannot take from mid of the piles. If the first, it will take from the first non-empty pile. And who will win the game? The person who will pick the last stone from the pile will win the game. So they both are playing optimally, and they will try to win the game. So we have to tell that who is the winner in the game. So see, if there are all one, then it will be simple because no one has any choice. First one has to choose this one, and second then second person will choose one from here. After that, first person, first person, second, first and second. So what will be the output? The output for the second will be second. The second person will win. But when we get choice, if we have the number of choice that have from here, first can pick one stone, and first can pick also two stone. So I think the problem statement is clear to you that we have given a piles. In each piles we have some number of stones, and first one or who have the term will pick a positive number of stones from a pile, and whoever will pick the last element or last stone from the pile, he will win the game. So I am giving you again 2 minutes. If you can make a approach for this, then try it once. Okay, try it. Just think about problem statement is clear to you, right? See, we have given a pile. Let's say there is also an explanation. So for the first one, we are going to see that there are 2 stones in first pile, 5 stones in second pile, and 4 stones in third pile. So the first person, what will we do? What will he do? He will pick one stone. So now we have 1, 5, 4. He have picked one element. So now what the second person will do? Second person will pick one stone from here. So now it is 0, 5, 4. Now what first person will do? First person will pick 4 stones from here, and then it will be left 1. So now what the second person will do? Second person will pick this first stone. So now our array will become 0, 0, 4. Now what the first person will do? First person will pick all the 4 stones from this array, and now it is 0, 0, 0. So who picked the last element or last stone? That is the first one. So our winner is the first one, that is here. Okay, so now I think a statement is clear, right? So try it. I am giving you 2 minutes. Try it. Okay, so just tell me what is coming in your mind. Not the proper solution, just tell me like what is coming in your mind after seeing this problem. How can you approach? Just think about the solution. It's really simple. Like I will tell you and you will see, oh, this is the solution. But the thing is that how much or how good you can observe. Okay, so I think no one is getting the solution or no one getting the approach. So I will discuss about the approach. Now let's say, okay, so now I am going to explain. Uh, so see, I will take the first I will take the first one, that is 1, 1, 1, 1, because this is the simple solution. So simple example. So see, if the size, in this case, only the size matters, because if the size is odd, see, so the first one will pick this, second, first, second, first. So size, if size odd hai, if size is odd, then who will win? The first one will win, right? Now, and if size is even, in which case, if all elements or all piles have only one stone. So if size is even, then who will win? The second will win. Now they are saying that uh, there are all no there are it is not compulsory that there are all elements should be one. So I am taking this case, just I have put the 1 1 in the starting. So see, in starting, the first person have no choice to pick element, so first person will choose 1 from here. Now second person also not have any choice, so second person will pick a element from here. So what it will become? 0 0 2 4 5. Now the turn come of first person. So see, now it is in the first person's hand that he want to allow the second person to move from here or not. Because see, if it will pick the one, if it will pick only one stone from here, so the case will become 1 4 5. So the second person has to pick element from here. But it is also possible that the first person will pick will pick all two elements from here. So the case will become 0 4 5. So now the second person has to pick a stone from here. So you can see here that if the first person get the chance or get the or can take the element as much as he want. So and at that time the control goes to in his hand. So see, if he will pick only one, then the second person has to pick from this index. And if the second he will pick all two elements, then second person will have to pick from here. So now all control is in the first person hand. Okay, so in this case first person will win, because what he will do, because they are playing optimizedly, so what he will do, he wait a second. He will pick one element from here and will stop the second person here, 1 4 5. So now second person have to this is the first person. Now second person has to pick element from this pile because it is not empty. So now the case will become 0 4 5. Now the first person is clever. So what he will do again, he will again pick only for 3 elements from here. So again here will become 1 and here will become 4. So now second person again get stuck here. So second person has to again pick from here. So now the first person is again clever. So he will pick all the 5 elements from here. So it will become 0 0 0. So see here when he get the element that is greater than 1, he has the all control to move the second person. He want to move him or not. So the first person will win. So the logic is that if the first person or the second person, whoever will get a integer value greater than 1, he will win, because he will get all the control of the second person. So in this case we are going to make our approach that see if the now we are dealing with index. So if if the index in array of I, see, if the index is even, then whose term it is? It is the term of the first person. 0 index, 2 index, and 0 index, 0 index, 2 index, and fourth index is the term of the first person. And the 1 index and 3 index is the term of the second person. So if the I is what I is even and array of I is greater than 1. In that case, who will win? In that case, the first person will win. And if the I is odd, that means it is the second person. So in this case, who will win? And array of I is greater than 1. So in this case, the second person will win. So is it clear to you? Hello? Is the logic clear to you? Okay, so should I explain in Hindi or English? Okay, hello. Okay, so I am explaining again in English. So see, I am saying just remove here. Okay, just remove here. Come here. 2, 4, 5. Now I will make the second person to win. So what I am doing, just one, first, second, first, second. Now I have changed the programs. Oh, I have changed the example. In this, it will be more clear to you. See, in this case, if the piles has only one stone, then the first person have no choice. He has to pick the pick this pile, pick this stone. So it will become 0. Now second person will come, and as this is 0, so he has to pick the element or pick the stone from the second pile. So it will so he has also not choice because it is 1. So he will choose 1 and it will also become 0. Now the first person will come and he has also not any choice, so he has to pick the element from here 0 and it will become 0. Now second person will come and here it is the number is the 4. So what he can do, if he will pick all the element, all the stones from here, so it will become 0. And and the first person will come and he has to pick stones from this pile, right? So first person has to pick from here and second person from to pick here. Now also in this case, as the second person has choice, so what he can do, he will pick only 3 stones from here and will left 1 here. So what here will become, here will become it 1 and here will become 5. So now where the first person is, the first person is here. So see, you can see clearly that it is in the second person hand that he want to move first further or he want to stop first person here. So what we want to, that here the aim of the second person is to reach here first, right? If he will reach here, he will pick all 7 elements and win the game. So as the second person get all the control of the first person, because he will left, if he will left 1 element here or 1 stone here, first person has to pick from here, and he will, if he will take all the stone from here, then first person have to take stone from here. So now as the control goes to in first person hand, then now the control has gone to the second person hand, so he will win the game. I think now it is clear. Hello, your voice is breaking. Okay, so now it is clear. Hello. Okay, so I am speaking again, and at the time the voice will break. At that time, please tell me. So I will stop. Okay. See, I will explain it again. That see, here the first person will come first, and he will pick the 1 stone from here, because the he has no choice. Here is only 1 stone, so he has to pick that. So it will become 0. Now the second person will come, as this has become 0, so he has to pick from this pile. So he has also not choice, has any choice, so it will also become 0. Now he will come here, and here and the here who will come, the first person. So he has now also have no any choice, so he will pick the 1 stone from here and it will become 0. Now let's say here is the main game. See, second person will come here. Okay, I will write it again. See, second person will come here. Now he has choice, he can pick from 1 here 1 stone, 2 stone, 3 stone or 4 stone. So what he will do, he is clever. So what he will do, he will pick all the element here from here, so it will become 0. So now the first person, see here was the second person, so now the second person has taken all the stone from here. So now the first person has to take stone from this one. And if he will pick, if the second person will pick only 3 elements from here, then here the rest of stone will be 1. So now the first person has to pick from here, because here is 1 element, here was 0, so he has to pick from here, and here is 1, so he has to pick from here. Now, so you can observe from here that the control is in second person hand, that if he want to move the first person further, then he will pick. Okay, so I think, hello, it is clear. Hello, is it clear? Hello, wait a second then. I think it is because of I have opened many windows, so first I will close them. Okay, so I think it is clear now. Hello, 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 is it clear now? Okay, so see, I will explain it from here. That is, see,